Good morning, everybody. Thank you so much for joining us today. My name is Jennifer Adams. I'm the marketing coordinator here at LPKF. Our presenter today is going to be Matt Liles. He is the Rapid Prototyping Sales Associate here at LPKF. And before we get started, we're going to ask a question to the audience just to kind of get a feel for where everyone is at. Join me real quick. So our question is, how long does it take your board to go from design to prototype, or from your computer and back from the board house? I'll give it a few more seconds, let a few people join on. We still have people coming in. Okay. All right, these are great. And after everyone has answered, we'll show the results with everyone so everyone else can see, where everybody's at. Okay, I'll give it about 10 more seconds and then we're going to close it out. Okay, closing the poll. All right, so here's everyone's results. So 33% of you say your turnaround time is about 1 to 2 days. 11% say it's 3 to 5. 33% of you say it's 1 to 2 weeks. And then 22% of you say it's more than 2 weeks to get your board from design to production.
That's interesting. That's more 1 to 2 days than I would expect. I wonder if we have some LPKF customers online with us today.
Possibly, yeah. All right. So at this time, I'm going to turn it over to Matt.
Hello, everyone. Thank you for joining us this morning. We're going to start things off by looking at a few of the benefits of in-house PCB prototyping. First, as we just showed, the majority of you are currently waiting 1 or more weeks for your projects to come back from the board house. And those of you that are only waiting a day or two are probably having to pay considerable rush fees for those faster turn times. With the LPKF in-house PCB prototyping equipment, you can shorten your turn times from days or weeks to hours or minutes. 86% of LPKF users report saving 4 days or more per project, and of those, 58% save 1 week or more per project. This time save leads to greater project momentum, increased productivity, and a quicker time to market. Reason 2, money saved. Customers that run as little as 2 to 3 projects per month have reported as being able to see a return on their investment of a ProtoMat system in as little as 1 year. Reason 3, more process control. Since your design never leaves the office, you don't have to worry about your projects being sent overseas and your designs potentially being copied. And finally, increased innovation. LPKF ProtoMat and Proto Laser systems allow you to try different designs on a variety of materials to create the best possible product. Why LPKF? LPKF originated PCB milling over 40 years ago and has set the standard and led the market in sales and system advances. The precision and accuracy of the LPKF ProtoMat systems allow for the creation of production quality prototypes. LPKF is a trusted industry leader, and we offer product support for the life of your product. LPKF offers a wide variety of rapid PCB milling and laser systems. A few weeks ago, my colleague Jason Hicks introduced our entry-level E34 and E44 systems. Today, we're going to focus our attention on the more advanced S-Series systems. The LPKF ProtoMat S-Series systems allow for features as small as 4 mil trace with 4 mil spacing, with through holes as small as 6 mils. They offer a 9-inch by 12-inch working area with the ability to step and repeat your designs to create multiple boards on the panel, and are able to contour out the board outline to singulate your PCBs. The ProtoMat S63 and S103 are recommended for multi-layer designs and are able to create up to 8-layer PCBs. The ProtoMat systems are high-quality German engineered. Each machine is individually calibrated and offers half-micron resolution with 1 micron repeatability. The ProtoMat systems offer the fastest maximum travel speed of any PCB milling system available at 6 inches per second. Let's take a look at each of the S-Series ProtoMat systems and outline a few of the features that are offered. We'll take a closer look at some of these features later in the presentation. The LPKF ProtoMat S63 is the ideal system for virtually all in-house prototyping applications. The standard features include a 60,000 RPM spindle motor, 15-position automatic tool change, automatic depth adjustment, optical Fiducial camera, acoustic cabinet for quiet operation, solder paste dispenser, and a software controllable Z drive. The ProtoMat S103 is the most advanced model among the S-Series. The fully equipped system is suitable for almost all PCB prototyping applications. The S103 offers all of the features of the S63, plus the highest available 100,000 RPM spindle motor, pneumatic depth limiter, and offers a vacuum table as a standard feature. Let's take a closer look at some of the features that are included with the ProtoMat S63 and S103 systems. The first is the 15-position automatic tool changer, which includes a graduated ramp to set the milling depth automatically. This allows the ProtoMat system to operate virtually unattended and allows the operator to work on other projects while the PCB is being milled. The Fiducial camera is one of the best features that has been added to the ProtoMat systems over the last 20 years. The camera allows for optical registration of the PCB for precise front-to-back alignment, as well as alignment for 4, 6, or even 8-layer boards. The camera is also used to verify cut widths, to calibrate the depth ramp for the automatic tool change. The vacuum table is offered as a standard feature on the S103 and an optional feature on the S63. In addition to eliminating the needs for set pins, the vacuum table secures the board material flat across the work surface, eliminating any warp or bowing of the materials. The vacuum table also allows for application of ProConduct through-hole plating system. The included CircuitPro software is able to import most standard CAD/CAM files, such as Gerber, GerberX, DXF, HPGL, Exelon, STEP, and many more. CircuitPro is extremely user-friendly and includes wizards to help walk users through the process of calculating the toolpaths and operating the ProtoMat to make PCB milling process easy and efficient.
At this time, we're going to ask one more question to the audience. And this question is, what type of circuit board applications are most important to your business? So we'll give everyone a few moments to answer. Wow, you guys are really coming in quick. We can actually close this out in about 10 more seconds. Just give everyone a chance to get their answer in. Okay, at this time I'm going to close the poll and share everyone's answers. So 38% of you say that digital design is the most important to your business. 31% say analog, 8% say RF microwave, 8% also say LED lighting, and 15% say other.
Looks like we have a lot of digital and analog customers on with us today. LED lighting occasionally uses requires a larger working area. We do offer larger systems as well. If that's something you're interested in, please feel free to contact me. I'm happy to answer that. And then those of you answered other, I'm curious to know what those are. If you're interested, please contact me at the end of the presentation, and I'm curious to discuss your projects.
We also have time at the end of the webinar to open up the board for questions. So feel free to ask a few of those at that time as well. And right now I'm going to let Matt take over.
So the LPKF ProtoMat S-Series systems are going to allow you to create digital and analog applications, including power boards with heavier copper weight, as well as metal core or aluminum backed materials, which are often common in LED applications. They're also able to mill RF and microwave boards using a variety of RF materials such as Rogers and Taconic. ProtoMat S-Series systems even allow for applications using flex or rigid flex materials on industry standard DuPont materials, etc. As I mentioned earlier, the ProtoMat S63 and S103 systems include a software controllable Z drive for 2.5D milling. This allows for step milling of aluminum, brass, copper, and plastics for the creation of housing, fixtures, heat sinks, or even faceplates. The S63 and S103 systems are even able to apply solder paste automatically based on your cam designs on pads as small as 0.4 millimeters. As we show, the LPKF ProtoMat S-Series systems will allow for creation of digital analog boards as well as RF and microwave from 1 layer all the way up to 8 layers on industry standard board materials, including delicate materials such as gold-plated. They will allow you to create production quality prototypes in a matter of minutes, so your boards are ready before lunch and enables you to create multiple design iterations in a single day. With the various systems, features, and capabilities, LPKF allows you to dial in the perfect machine for your current and future prototyping needs.
All right. Thanks, Matt. So at this time, we'd like to open it up for questions. Any questions you may have, we will take them now. Okay, our first question. Does the CircuitPro software work with Windows 10?
Yes, the CircuitPro software will work with Windows XP or newer. That's going to include Windows 7, 8, and even Windows 10 software.
Okay. Next question comes in. Is there a difference in the trace and space between the two systems?
So with the S63 and the S103, the trace space is going to be the same, 4 mil trace, 4 mil spacing with both those systems. The 4 mil spacing is really limited to the tooling. 4 mil tooling is the smallest we would recommend with the ProtoMat systems. Just due to going down below that, the tooling becomes very delicate and does not have very long tool life.
Okay. Next question. Does ProConduct work with high current traces or vias?
So ProConduct, it works nearly identical to copper, but if you're working with high current, it doesn't allow the exact same. It does offer a little more resistance than copper does. For high current, it may work, but actually, I don't have any customers working on that. I can do a little research and get you some better answers on that.
Next question. I have had issues with using the camera driver on Windows 10. Had to update it to the Anniversary Edition to fix that. I just thought about sharing that.
Well, thank you for sharing that. I will definitely pass it along to our support team and make sure they're aware of it and see if they have a solution for you on that.
Okay, we have from the same person. Can we do multi-layer flex boards?
Yes, with the LPKF ProtoMat S-Series systems and the addition of the multi-press, you were able to do multi-layer flex boards as well as rigid flex lamination.
Okay. Next question. How long does a system last?
So the systems are designed to last 8 to 12 years. In fact, we actually have a number of customers that are still operating machines that were released over 20 years ago. So they do have an extremely long lifetime.
Okay. How long do the drill bits last?
So the life of the drill bits is going to vary depending on the size of the drill bit. The smaller bits are obviously going to have a much shorter lifespan But typically you're looking at several thousand holes for each drill bit.
Okay, another question. How much does it cost to make a board?
So the cost of creating a PCB is gonna vary from board to board, and depending on the design, the materials you're working with, how much copper removal you need to work with. But we find the average cost for a 3 by 5 inch PCB is about $6.50.
Okay, we'll leave it open for a little bit longer. Let people ask any other questions they may have. Okay. Will these machines be upgradable if improvements are made, say, 10 years down the line?
So the machines are currently upgradable now. If you purchase the S63, it can actually be upgraded up to the S103 system. You can add the additional 100,000 RPM spindle and the pneumatic tool change. Additionally, the S63, you can add the vacuum table, as we mentioned earlier, as an optional feature. As products become upgraded down the road, it's possible we may retrofit some of these upgrades back to the S-Series systems, but that's for the engineers to figure out, and I don't really have an answer for that right this time.
Okay. How does the system connect between the layers?
So when you use the multi-press system, which is used for lamination of the layers, you're going to use a pre-preg material. It's going to use a combination of heat and pressure to bond those board materials together using that pre-preg.
Next question. Why is a higher spindle rate better than the lower one on the S63?
So the S63 is going to give you the cleanest cut possible on FR4, woven materials, more rigid materials. When you start working with softer materials, such as Rogers Duroid 5880, 6000 series Rogers Duroid materials, or even Flex, the faster 100,000 RPM spindle will get you a cleaner cut on those softer materials.
And then, how do you perform maintenance on the system?
So maintenance is pretty basic. There's not a lot of maintenance involved in this. The biggest thing is you have to make sure you keep the ProtoMat system clean. Keep from buildup of debris on the lead screws, and the system will operate with very little maintenance. About once a year or so, you'll need to lubricate the lead screws, and then every 250 clamping cycles of the collet, the system will prompt you to clean the collet. And if you have a user who's never done that before, actually it'll bring up a video that shows you exactly how to go about the collet cleaning process, which takes a matter of just a couple minutes.
These are some great questions. Okay. What do you do if a lifetime of the tool is completed?
So if you're beginning a board, first of all, the software will track your tool life of the project, of the tools. So if you're beginning a board and the tool life isn't going to be long enough for that particular board, you're able to either load a new one right then and there, and the machine will automatically move to the next tool and continue milling with the next tool. It'll also give you the option that you can have it prompt you that the tool is expired. And our tool settings are a little bit conservative to make sure you're not going to get burrs with the tools before the tool life expires. So you can look at your project, and if it's almost complete with that tool, you may be able to finish out that board without changing the tool. So the software gives you a couple different options, whether you will load a new one and have it switch automatically, or have it prompt you, and you can make the judgment call at the time whether you want to change the tool or not.
Okay, another question. What are common problems with new users who haven't been properly trained on the machine?
The biggest issue new users may have with having been properly trained is just making sure they're loading everything properly, making sure the depth is set. New users may not have maybe milling too deep, and may not properly calibrate the tool ramp when you're loading your tool material. Other than that, the software is extremely easy. As I mentioned, the wizards will walk the user through pretty much step by step through the process. And then for more experienced users, you don't have to use those wizards, and there's even more advanced features that the software enables you for.
How do you create a stencil from the ProtoMat S63?
So with the S63 or S103, even the entry-level E34 and E44 systems, you can create polyimide stencils. You'll use a V-shaped tool. You use what we call a universal cutter tool, and it will actually mill the polyimide stencils for you, which you can put into our stretch frame, our ProtoPrint stretch frames.
Let's see. So another question, how do you do drill holes for through-hole plating?
So the ProtoMat system with that 15-position automatic tool changer, you can load those drill bits directly into the tool change, and it will drill the through holes for your through hole plating process. If you're working with our galvanic plating system, our Contact S4 system, you'll drill the through holes first. It'll go into the plating bath, grow the copper in the through holes, and then you'll put it back on the machine. You can reload it using the optical Fiducial camera, and then go ahead and mill your top and bottom layers. When working with the Pro Conduct, you're actually going to do it in the exact reverse. You're going to mill your top and bottom layers first, and then you're going to put a protective foil over the top of the board, drill your through holes through that, and then apply the Pro Conduct to complete the board.
Okay. One of the issues we had with the multi-press system was that it runs at a different rating, 230 volt, than what is available in the US. Why a different rating for the multi-press system?
So the multi-press with the heat and then the hydraulic pressure for bonding the boards, it just requires a little more voltage to make sure it's able to ramp up to those higher temperatures. The ProtoFlow systems are also going to be in the same category with needing the 220, 230 volt power. It's just required to put the proper amount of heat into the boards. The ProtoMat systems will operate on standard 120 power as we have in most labs here in the U.S.
We'll take a few more questions if you have any. Okay. I think that wraps up our presentation today. Thank you everyone so much for joining us. If you do have any further questions that you'd like to ask Matt, he is available at mliles@lpkfusa.com or 503-454-4211. And that is the end of our presentation. Thank you so much for joining us. Oh, also, those who attended today will be receiving a link to download our white paper, Why In-House Rapid Prototyping. And thank you for joining us.